Okay.
So we have two different ways of simplifying radicals. Different teachers teach it different ways. I've always said that rewriting with multiplication to get a perfect square value, that's what I've taught you. So this is not a perfect square value, it's 32. So I always say make a perfect square number list. So I have my perfect square number list up here, and 32 is not up there in the perfect square number list. If it were the square root of 36, the answer would be 6. So we want a perfect square number in here. So you got to look at these numbers and think, what could you break 32 down to with multiplication? So you could say 4 times 8 is 32, but do a couple more seconds, take a couple more seconds and look at the higher perfect square numbers. 9 times something give you 32? No, it doesn't work. 16 times 2 gives you 32. So 16 times 2 is the same thing as 32, and you're able to split the roots. Then you end up with 4 square root of 2 as your final answer. So that's the way we've been doing simplification of square roots. Now other teachers explain the prime factorization method, also known as a factor tree. So where I say think of your perfect square numbers and break it down with multiplication so you can get a perfect square number, other teachers just say break it down with any two numbers you want. So you could say 4 times 8 if you wanted to. So if we did break it down to 4 times 8, that's okay. And then they say break down everything as much as you could. So 4 could break down to 2 times 2, and 8 could break down to 2 times 4. And this 2 is no longer able to be broken down. This one's no longer able to be broken down. This one isn't. But 4 could be broken down further. So 4 could become 2 times 2. Now, when you look at the prime factorization, anything that pairs up will ultimately go out of the square root. So right here we have a pair of 2's, which means that on your answer, you're going to have one single 2 on the outside. Okay? And then we have another pair of 2's right here, this 2 and this 2. That means you're going to have another 2 on the outside. And then we have the single 2 that doesn't pair up with anything, so that one stays on the inside of the root. So our answer actually is 2 times 2 times the square root of 2, which is the answer 4 square root of 2. It's the same exact thing over here, it's just a different way of doing it. This is called the prime factorization or the factor tree, where you just keep breaking down the number as far as you can. So let's compare the square root of 20 on both of these. Well, the way I said for you to do it is to think of a perfect square number that you could produce 20 with, but with multiplication. So instead of 20, we're going to say 4 times 5, because 4 is a perfect square number. You don't want to use 2 and 10 because 2 is not a perfect square and 10 is not a perfect square. So you are using 4 and 5 because 4 is a perfect square number. And then you're able to split the roots. And then the square root of 4 is really 2, and the square root of 5 just comes down. So that's your answer, 2 square root of 5. Now let's do this using the factor tree or the prime factorization method. Over here on the other one, let's take 20 and break it down to any two numbers you want. You could do 4 and 5, or you could say 2 times 10. It doesn't have to be perfect square numbers. And then you take the 10 and you break it down further. 10 breaks down to 2 times 5. So what do we have here? We have 2 and 5. Now remember, whatever pairs up will go on the outside of the square root. So here's our square root, and the 2 and the 2, these guys paired up. So there's one single 2 on the outside. And what about the 5 that did not pair up? That just goes on the inside. That's your answer. Okay, so the best way to understand both methods is to do several practice problems with both methods. I think we're pretty good at simplifying using perfect square numbers, but let's practice a couple more using the factor tree. That way, if you truly are struggling with this, maybe you'll get more success using the factor tree. The square root of 48. Using our original method, you want a perfect square number inside this radical. So we're going to rewrite it with multiplication to get a perfect square number. Now, yes, you could say 4 times 12, but it's better to rewrite it as not 4 times 12, but a bigger perfect square number like 16 times 3. 16 times 3 is 48. And then you're able to split the root, and you'll get 4 square root of 3 as your final answer. Okay, I really do like this method better, rewriting non-perfect square numbers with multiplication so you could get a perfect square number and use the highest perfect square number possible. But let's go with this prime factorization method. All you have to do is break it down, and it doesn't have to be perfect square numbers. For example, 48, you could break it down to 4 times 12. And 4 could be broken down to 2 times 2, and 12 could be broken down to 2 times 6. And then 6 could be broken down further to 2 times 3. Now, keep in mind that on your answer, you're going to have a square root, and the numbers that pair up go on the outside. So look, how many numbers do we actually have? We have 2, 2, 2, 2, and then 3. So the numbers that pair up go on the outside. So let me represent it with this green color. This 2 and this 2, they paired up, so I have a single 2 on the outside. And then I have this 2 and this 2 that pair up, so that's going to be another 2 on the outside. And then last but not least, the 3 over here does not pair up with anything, so the 3 stays on the inside. So what do we really have here? We have 2 times 2, which is 4, and the square root of 3. That's the same exact answer as we have over here. It's just done with a different method. Okay. Now, if you're wondering, well, why is it that I could take whatever pairs and put it on the outside? It's because 2 times 2 is really 2 squared, right? And 2 times 2 is really 2 squared. And when you do the square root of a square, it undoes itself and the 2 comes out. So if you like this method, go for it. If you like the original method I taught you, stick with the original method. I personally like the original method, but we could continue using prime factorization if you don't like the original method I showed you of replacing non-perfect squared numbers with perfect squared numbers using multiplication. Let's take a look at the square root of 128. Now, thinking about the perfect square numbers, you could use a calculator, and you could rewrite 128 as 4 times 32, but then that would be more work. 4 is not that high of a perfect square number. So think of a higher perfect square number. Maybe 9 might work, maybe 16 will work, maybe 36 will work, maybe 49 will work, maybe 64 will work. And in this case, 64 does work. So we want to use the highest perfect square number we have, which is 64 times 2. Then you split the root, and the answer will be 8 square root of 2. Now let's do this same exact problem, but with the other method, the prime factorization or the factor tree. So 128, you could break it down to anything you want. You could say, okay, 2 times, 64. 2 times 64. And then the 64, you could break it down to 2 times 32, right? And then the 32, you could break it down to 2 times 16. And then the 16, you could break it down to 2 times 8. Then the 8, you could break it down to 2 times 4. And I'm running out of space here. And then the 4, you could break it down to 2 times 2. So what do we really have? We have 2 times 2 times 2 times 2 times 2 times 2 times 2. That really is 128. Now, again, your answer, whatever pairs you're going to be able to write on the outside. So this first 2 and the second 2, that's a pair of 2s. You're going to write that on the outside as 2 times. And then we have this 2 right here and this 2 over here. You're also going to go 2 times. And then we're going to have this 2 right here and this 2 over here. It pairs up, write it on the outside 1 time. And we do have a leftover 2 that we're just going to write on the inside. So our final answer is 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. Square root of 2. Now if we compare, we have the same exact answer. It's just, I think this method is a lot better. But if you're not good at seeing perfect square numbers, then you may just want to break it down as much as you possibly can and then start pairing up the same numbers. So 2 and 2 is right there. This 2 and this 2 is right there. This 2 and this 2 is right there. And this leftover 2 that did not pair up is on the inside of the root.